So just to recap what's going on in plot color quantization.py, basically we have the minimal number of colors we've chosen for the clusters. We have a base image called China, which has the full number of colors, 96,000 colors. We're going to convert that into a number array for the bit integer coding, which basically allows us to then apply or compare that image to other images that we will then input. That is the base image, the comparison image with the 64 k-means cluster chosen image, that is, versus the random selection image. So we'll use that to convert. So the NP array does that, allows us to make these things comparable. And then we have the original image changed to a tuple, which gives us the dimensions of the image. And then we'll create, reshape that image array once again, once we've then determined the image shape. So we can now go ahead and try to create the image, or we display the image rather down. We'll see later on in the code. But first, what we're going to do here is actually then going to create a random selected, or rather an image selected using k-means clustering. So once again, we take the image array, which is the same dimensions for the second image. So that is, we're taking effectively the same image, shuffling it, so that gives us a sample, and then applying the k-means cluster on a number of colors chosen, that is the 64. No random states. We fit that image to the sample size, so that gives us the k-means cluster image. And then finally we do the prediction, which allows us then to do the fitting, predict the number of labelings, so that gives us the 64 colors effectively that we want. And then finally we do a random one, random selection of the 64 number of colors. So we take the same number of colors, as you can see here. We randomly select the number of colors, and then we apply them to get the labels that we need, the 64 random colors effectively. And in the bottom code, what that does is basically show those images. So we show the China image, we show then the recreated k-means cluster image, and then we recreate the random selected image. And then you can see in line 131 there's also an error measurement. This is basically using what's called mean standard error to look at the error between the k-means cluster image and the base image, the China image. You can see the method called MSE. Basically, it subtracts the one image with the other, multiplies that difference, and then will then, or rather square that difference, I should say, and then return the float value. So it's the sum of the squares, basically differences between the two images. Okay, so by taking the sum of square differences, we are trying to determine the differences between the two images. So what you want to do with the MSE is effectively get the least or the smallest value. So the smaller the value, the smaller the number of error in terms of the sum of the square differences between the two images. So you want to return a value that has relatively low number for the MSE. And then you can see the other method that we do is have the recreate images, which is the main method that we use to effectively create an image from given set inputs. So the code book that's used, the compressed images, labels used for the colorization, as well as dimensions of the image, that allows us to actually then create the specific image that's used to then compare between the images as well as the base image itself. Okay, so that's basically what we're doing, is applying both the k-means clustering imaging, the random selected image, and comparing it to the China image, which is the base image. So once again, you can see when we ran the code, we got a k-means, or that rather an MSE error of 0.0019 something, so that's a relatively low value. So that means the 64 k-means cluster image selected colors have a relatively low value of error when compared to the base image. That is, the images are basically very similar. So the MSE tells us how similar the two images are, and that's what effectively the MSE calculation is doing in this case. Okay, so once again, I'll run it and show you what's happening. So it tells you how fast the code runs, and here you have, again, the quantized random image, the quantized k-means selected image, and the base image. So once again, the k-means image is fairly similar to the base image, whereas it's very different in terms of the randomly selected color image in terms of the image quality. Okay, and the final thing we want to look at is, of course, the error, which is 0.0019. That is the MSE error, a value showing that the two images, the k-means color selected image and the base image are fairly similar to each other in terms of how they appear. Okay, so that's pretty much it for this week. Hopefully it was clear. We'll be going over this code of course in class and discussing it more in detail. This is one of the methods that we'll be discussing in terms of machine learning. Next week we'll be applying more advanced methods. So you'll see this week hopefully gives you a sense of a fairly standard methodology used for machine learning, particularly for image analysis.